This presentation is on the generation of Plexus 3D models from gINT. What is being generated are models of the stratigraphic units stored within gINT for finite element analyses. What's generated by gINT is a command file, which you then run within Plexus 3D to complete the process. And only the geometry is exported from gINT. The unit properties for the different materials need to be input within Plexus 3D. This capability requires gINT V8i SS2 or later, and you must be licensed for gINT Professional or gINT Professional Plus. And it also requires Plexus 3D 2010 or later, including the command runner tool and the expert menu, which requires the Plexus VIP licensing. So the command is executed with an input on the currently open project. It's under the File menu, Import Export, and then Export to Plexus 3D Layer File. This dialog is then brought up. You specify the file name you want to generate to, and then various fields and tables for where the program gets the requisite information. And all of this is remembered between gINT sessions. The information in this dialog is stored within the project. So what you're specifying to gINT are the coordinate information about each borehole, which generally comes from the point table, but you could specify another table if you wish, and the stratigraphic units, different than layering, which we'll discuss in a moment, and that can be any table you wish within the database. And this information then generates these models. On the gINT database side, you need coordinates and elevations for each borehole, and you have to have a depth-related table with top and bottom depth for each stratigraphic unit. And a stratigraphic unit is generally different than your layering, which a lot of people call lithologic units. You could have multiple layers as shown here within the same unit. A unit encompasses layers that have similar properties for whatever you're analyzing. If you're analyzing deformation, similar deformation properties, or strength, etc. And generally, just using the graphic, the material type, is not sufficient, because certainly within a borehole, it's very possible you could have clay, sand, clay, sand, clay, sand. And as we'll see later, that can't be used within the model, the stratigraphic model. So let's look at the Plexus model requirements. You have to have consistent unit sequences in all boreholes. So this is correct, these two here. You can name your units anything you want. To make it easier to understand, we've just used the letters and in order. And the order has to be the same between boreholes. And this one here is missing a layer, and layer C. And that unit must be there. And one of the capabilities of this facility in gINT, we will provide it for you. We will insert a zero thickness C layer in this case. You do not have to worry about that. Your work is to come up with the units and make sure they're in the right sequence, and then we'll take care of places where certain units are missing within boreholes. This is incorrect. Here, the B and C are reversed from the other. This will stop the output completely. If you have boreholes with the wrong or different sequence, the program won't export anything, and it will tell you that in an export log. You also cannot repeat a unit in the same hole. So here we have A, B, C, and then A again. That would abort export of that specific borehole. The other boreholes would be exported. And of course, the exception to this rule, if you repeat the same unit and they're contiguous, So you have 3 A's in a row, as we showed in the earlier slide. That's okay. The program will consolidate those into 1 A unit for you. Holes must be vertical down, and the program will check both the plunge field in the point table, which is a native field in the program. It must be -90 or blank, which is the default, -90. And it also checks the point orientation table, which allows multiple deviations of the hole. For those not familiar with this table, you can add it in input. It's under the additional modules menu. And finally, the borehole and unit names have restrictions. Don't worry about them. Name them whatever you feel like naming them, and gINT will handle those restrictions and rename them appropriately. And then you will get an export log when you're completed, and if there are any problems, you will get these. And here we have a number of them. And holes that are not vertical down, hole layers that are not contiguous, you have gaps or overlaps, bottom depth less than top, etc. Pretty obvious kind of errors. All right, let's take a look at it in action. So it's under File, Import Export, Export to Plexus 3D. Now, this is a database I have not worked with yet, so it does not remember any of the previous values because there were none. And the table with location data. Now, this will show you all tables that are at a point level key set. They would have to be either the point table itself, which is built into the program, or a one-to-one child of point. And you specify where to get the coordinates and the elevation and the layer table. Oops, not graphic, we want the unit. And then you can pick specific boreholes, or if you leave it blank, you get them all. And then this will be remembered between sessions once you've done it once. And there are no errors. It tells us what our files were and the boreholes that were exported. All right, let's take a look at this inside of Plexus. All right, so we're in Plexus. We're going to start a new project, call it gINT. Now, there's also model properties. You need to put in your units. The gINT file will not provide these. However, it will fill in these values to the extent of the boreholes. So you don't have to worry about this, only your units. We go under Expert. Run commands, and we're going to open that file. And here it is. And we're going to run it. All right, it's been imported. And let's go into perspective view. There's our model. Here are our boreholes. And the head of water for each of these, of course, has not been imported, so you need to provide that if it's relevant. And the different soils are here. We have these 6 layers, units, and again, no material. You must provide those. Right. So in summary, we've demonstrated an easy transition of data from the reporting stage of the project lifecycle to the design stage without additional data entry. This saves time, eliminates data reentry errors, and allows engineers to focus on engineering tasks and what-if scenarios. For example, an engineer may have doubts to which unit a layer should be assigned to. With this tool, you can easily evaluate multiple cases of unit configurations and elect the most appropriate configuration. And this also eliminates a lot of tedious manual manipulation and validation. So we take care of the zero thickness layers, and borehole and unit names are adjusted if necessary, and there's extensive error trapping by the program, which helps eliminate most problems before you even attempt to bring it into Plexus. There's additional documentation. If you go under Help and Search, just type Plexus, and this first topic will give you a lot more detail. Thank you very much.